안녕하세요. 커피바이입니다. 지금 보고 계신 이 영상은 미국 오리건 대학교의 물리화학자이자 커피과학의 선구자 크리스토퍼 핸든 교수님과 나눈 인터뷰 시리즈의 세 번째 이야기입니다. 1부에서는 커피를 단순한 기호식품이 아닌 물리와 화학의 복합물질로 바라보는 핸든 교수님의 철학과 그가 어떻게 커피의 세계로 들어오게 되었는지를 이야기 나눴습니다. 왜 과학자가 커피를 연구하게 되었는가라는 질문에 대한 진솔하고도 흥미로운 답이 담겨 있었죠. 2부에서는 커피 추출 과정 속에서 벌어지는 정전기 현상, 분쇄 입자 분포의 차이, 샷타임 조절 등의 개념과 전기 자극 기술 같은 매우 구체적이고 실험적인 연구 시연을 통해 커피가 어떻게 더 맛있어질 수 있는지를 과학적으로 설명하고 시연하는 시간이었습니다. 그리고 이번 3부 영상에서는 이 모든 실험과 발견이 실제로 커피 산업에 어떤 영향을 주는가, 그리고 전 세계 커피 시장, 특히 한국 시장과는 어떻게 연결될 수 있는가에 대해 이야기합니다. 우리는 단순히 커피를 잘 만들고 싶다는 마음에서 출발하지만 잘 만든다는 기준을 명확히 이해하고 반복할 수 있도록 도와주는 것이 바로 과학의 역할이라고 핸든 교수님 말합니다. 또한 한국 시장의 커피 다양성과 소비자 수준, 바리스타와 로스터의 열정을 매우 인상 깊게 보고 있으며 한국은 협업과 연구의 기회가 무궁무진한 시장이라고 강조합니다. 특히 그는 바리스타의 미세한 실수까지 잡아주는 전기 기술, pH와 정전기, 물 조성과 그라인딩을 넘나드는 정밀한 연구를 통해 누구나 쉽게 좋은 커피를 만들 수 있는 시대를 만들고자 노력하고 있습니다. 이번 영상은 단순한 연구 소개를 넘어서 커피를 사랑하는 바리스타, 로스터, 소비자 모두가 함께 생각해 볼 수 있는 실질적인 통찰을 담고 있습니다. 과학이 말하는 커피의 미래, 그리고 그 중심에 서 있는 핸든 교수님의 이야기, 지금 함께 만나보시죠.
Your research on the chemical composition of water and its impact on coffee flavor and extraction efficiency has greatly influenced the industry. What inspired you to start this research?
So in 2014, I was a graduate student at the University of Bath. And that's when I met Maxwell Kalana Dashwood. And he was, at the time, not roasting coffee. Instead, his cafe was selling other people's coffee. And one of the coffees in the cafe was not tasting good. It was tasting like phenolic, heavy, maybe fishy. And after a lot of discussion, we started to understand that it was probably the water chemistry that was affecting the flavor rather than the coffee itself. And so I didn't realize at the time this was an important problem. I figured, so, I mean, it doesn't just pick a different coffee. But it turns out that as you know now, and as I also have learned over the years, that everybody has different water. And if you're a company that sells coffee, you are relying on the person who's going to brew that coffee to have water that makes your company's product taste good. And because of that, I learned that the industry cares a lot about science. And as a result, this is what got me into it in the first place. After that, I felt like water chemistry was, I don't want to say a solved problem because we didn't really solve it. We just explained why it's a problem. The solutions have come after we published the book. There was people who started making water that third wave water equivalent, where you add minerals. These products started to exist. That for me wasn't my intention. My intention was just to teach people why it's a problem, not necessarily to solve that problem.
What do you think are the most important factors in determining the optimal water composition for coffee extraction?
Well, originally we thought magnesium and calcium were important. I think that the most important thing now is how much bicarbonate is in the water, how much buffer. Because I can brew good coffee, some tasty coffee in soft water. And sure, maybe it's not as good as if it had magnesium and calcium added to it. Not as good. But if the water has bicarbonate in it, there's no way you're ever going to get acidity to come through that cup. And I think people like acidity more than they care about having this like structured, nuanced bouquet of flowers that you and I probably enjoy.
Okay, thank
Contributor.
you. In regions like South Korea, where water hardness barriers, what advice would you give to optimize the coffee experience?
Yeah, Korea is a challenging market to solve this problem in because there's a lot of coffee shops in Korea. And there's also pretty large variability in water chemistry in Korea. So in Seoul, it's fed by different water supply than down south.
Okay.
And certainly inland, you have different water than near the coast. And so as a result, the best way to solve this problem is probably to use reverse osmosis to take out everything and then maybe remineralize a little bit to get it to really soft. The problem with that is that is not trying to achieve excellence. That's trying to achieve average, like standardize the water. If you want to do excellent, you buy deionized bottled water and then make the minerals, add them yourself. That works great. Of course it works great. That's what the book is about. The problem is it's very expensive and it takes a lot of time. And most people who are drinking coffee don't have that time. Maybe in coffee competitions, it makes a lot of sense to do this because you need to win.
I asked about coffee grinding and extraction efficiency. You studied the relationship between coffee bean temperature, grind particle size distribution, and extraction efficiency. How can this research particularly benefit the industry?
Yeah, the industry is in an interesting position right now where coffee prices are increasing. It's expensive to buy coffee, roast coffee, sell coffee, run a cafe. At the same time, there's this societal motivation to pay more for coffee because it gives the farmers more money. And then at the same time, maybe charge people more in your cafe for coffee because you don't make enough money as a cafe to exist. So we have a problem, is that we want to pay people more, but we don't want to charge people more. So there is a solution to this problem, which is to find a way to make the product you sell as high quality as possible, but use as little as possible to make it still taste good. And if you think about the problem that way, then the goal is how do I extract as much tasty stuff from coffee as possible and waste none of it, but do not accept bad flavors. You must always have good flavors. And so the experiments that we've been doing are, okay, we just take the grind settings, grinders that everyone uses in the industry, and we prepare coffee in a really careful way so that we measure how much we are wasting. And when you do that, you can identify pretty large amounts of waste that are coming from simple things like static electricity formed during grinding, or perhaps thinking that shot espresso times need to take 35 seconds when it turns out that actually you start imparting negative flavors in long times, and what you might want is quick shots. So these sorts of things are the areas that we've been looking at, not necessarily thinking about my flavor preference or yours, but thinking generally about if I am given a coffee, how much of it can I extract? And what parameters dictate that? If you then tell me I don't want to extract beyond this point, great, then that's all the coffee has to give. But we want to make sure that we extract all the good. So the lab has spent a lot of time thinking about this, and the basic science contributions are understanding static electricity during grinding, developing a mathematical model for espresso and showing the grind settings. At some point, grinding finer doesn't mean you get more surface area. These sorts of things. They're simple concepts, and most of the time, baristas, roasters like yourself have known these things. When you dial in espresso, at some point you know you're not able to get better out of it, right? We've seen this. So I'm not really saying we're inventing or discovering anything, but we're doing really thorough experiments to put very well-defined numbers on each of these points. So how much did we waste, for example, if you grind without water and you make espresso and you change nothing but just add water, you're now able to get like 10 to 20% more soluble mass in the cup. And that's a lot. I mean, 10 to 20% more soluble mass is you know, that you can think of it as like every 5 espressos you make, you get a free one. Right, so that's a lot.
How do you see scientific approaches positively impacting the quality control and production of specialty coffee?
And so I mentioned to you earlier that specialty coffee is good,
Yeah.
and people in specialty coffee enjoy the fact that Ethiopian washed coffees this year taste different than last year.
Yeah.
And we like that sometimes Ethiopia coffee can taste very bright and floral, and other times it can taste more delicate and nuanced and subtle.
Yeah.
And we enjoy that there's differences. The question of basically, I don't want to change the way that specialty coffee, the business of specialty coffee behaves. I want to embrace differences in flavors. I want all Colombian coffees to taste different, not all the same.
Yeah.
So we're not trying to achieve this idea of homogenization of coffee flavor. And we're not trying to achieve, at least I don't think we're trying to achieve, the idea of elevating perhaps maybe one origin rather than another origin. In the specialty coffee world, what we're trying to achieve is put the ability to access good tasty coffee in the hands of the baristas and teach the roasters how to roast coffee so that the baristas can make coffee taste better more easily.
Oh.
And by better, I don't necessarily mean this shot tastes better than this shot. I mean better in the sense that these two taste the same, which is a really challenging problem, right? So for us, it's our contribution to specialty coffee it's less about pushing the upper limit of excellence. It's more about understanding what parameters determine flavor outcomes.
Okay. As an SCA trainer, what should I focus on to integrate the scientific research into educational program?
Yeah, well, you and I are similar.
Yeah.
I'm also an educator, not an SCA educator though. You're at the university right now.
Yeah.
So when we think about teaching, there are two different mentalities. One mentality is to take the most actionable, the thing that you can use tomorrow. I can teach you how to use it tomorrow.
Yeah.
So for example, do I squirt water on my coffee when I grind and it makes espresso behave more predictably?
Yeah.
You could teach it that way. The SCA trainers tend to teach it that way. They teach you what you need to know so you can do better tomorrow. I come from the other side,
Yeah.
which is I teach you why.
Why?
Yeah. And whether or not you use that for anything is a totally different problem. Mine is less useful
Yeah.
because tomorrow you won't know how to do anything different. It'll be the same as what you did today, but you'll understand why it happened.
Why happened?
Yeah. So for the SCA, you and I have two different jobs. Like your job is you're taking what I am doing and then turning it into something that people can use. My job is to find out ways to teach you how to do that.
Yeah.
I think all angles of this are good. If I had to write down what the SCA should probably teach people from what they've learned in this lab, I would say that from the grinding side, static electricity is a problem.
Yes.
Dark roast coffees at the same grind setting produce smaller particles than light roast coffees. So if you have a dark roast and a light roast, you need to grind coarser on the dark roast to get the same extraction.
Yeah.
These are things that you already know, but these are products of this. And if you want to turn off static electricity, you add water to the whole beans for that experiment. The next experiment that I would say most people, the SCA still has the definition of espresso.
Yeah.
That definition is changing, but my lab has demonstrated over the years that making espresso shots quickly, so shot times between 7 to 15 seconds, which is very fast,
Yeah.
they can still be okay. And previously, I think anything less than 25 seconds was viewed as not okay. So perhaps from my side, it would be like, remember to taste what you're making, because if it tastes good at 7 seconds, then why would you not make it at 7 seconds,
Yeah.
right? And then I think the final thing, at least what we've been doing and what I showed you today, we haven't published it yet, but it's important, is that the future of coffee, at least from my lab, is applying electricity to coffee. And it's powerful, and it can do things that we previously thought were impossible. So I think that when the time comes, there's going to be a pretty significant amount of education required to teach people how to do this properly.
Yeah.
Because it's not simple. You have to put electricity in there, you have to pick the voltage, you have to do all this stuff. And so the solution is not as simple as connect the AA battery and just put it in. It's more involved. And so at that time, we're going to have to work closely together to learn how to teach people.
Yeah.
But like today, the best way to teach that is to taste it. And you say, these taste different.
Yeah.
And they're really different.
Really different.
Yeah.
Korea has grown into a major coffee consuming nation. How do you see the potential for research collaboration or program development in the Korean market?
Yeah, so there's a lot of cafes in Korea.
Yeah.
And I was saying to my student at the back earlier that, as you know very well, the market is so big that Korea captures every type of coffee that you could consume. It is consumed in Korea, ranging from very cheap, very dark roast coffees, all the way to extremely high-end specialty coffee like what you sell.
Yeah.
Within that market, that means that is a mature market. That is a market like buying a car. There's a cheap car that people buy, and there is a expensive car people buy, and they buy everything in between. Which means that if you enter the car market, there's always going to be a market for you. Korea is the same. The problem with that is that there are people who like really sweet drinks. They like to add sugar and milk and all these things, right? And that market, it is not well suited to specialty coffee. Not because we can't make the person who enjoys the sweet drink enjoy specialty coffee, but because specialty coffee doesn't taste good in the sweet drink. It needs that like extremely dark flavor to come through to match with the other stuff, right? Because of that, it's hard to imagine how you would displace that portion of the market in Korea and make them more interested in single origin offerings, even if they're still roasted dark. You know, just make them interested in the specialty side. That doesn't mean there's not an opportunity there. It just means there's something to think about. From a scientific side, the thing that allows science to happen is money. I don't have a company, so I don't make money.
Yeah.
I only spend money. Every dollar that comes into this laboratory, I spend on people or equipment or coffee or something. The reason this business model works is because the finding that we generate of saving 10% every single shot of espresso, that's not good value to you as a small company. It's not a good value to even a big company. But all the companies together, it is good value. All the companies need to come forward with a little bit of money, just a little bit. But together it makes enough money to do something big like what we've been doing down here. In Korea, that market is perfect for this. Because if every cafe could part with $1,000 in 1 year, just $1,000, which some companies that's a lot of money. Other companies that's nothing. That's whatever. But if everybody in Korea put forward $1,000, that's a lot of money. That's several $1 million per year, and you'd be able to do a lot of good science. We're not at the stage yet where people are all organized, and the main challenge with that is the desire of the specialty cafe that wants to push the limit of excellence, and the desire of the cafe that makes the sweet drink with milk. Those two desires are probably different. So until we have a common focus point, it's going to be hard to imagine scientific advancement coming from the cafe level market. It could come from the green buying market, because that's where real money is. The green importers, because they have, they spend hundreds of millions of dollars. So that's perhaps one area where it might play a role.
Okay, thank you. What has been the most memorable moment or discovery in your coffee science research?
Every day we have something new and exciting. We publish on the most interesting stuff when it's ready. But the most rewarding steps, the most interesting steps are two things. The most rewarding is when we publish a paper and it appears online and other people read it.
Yeah.
The most interesting is when students come to me with new ideas and new information, and it's something that they've discovered themselves that I've never seen and nobody has ever seen. And so for a very short moment in time,
Yeah.
we're the only people on earth that know this thing.
Oh, yeah.
And then we tell people about this thing. That's our job. And so you don't get into science because you're interested in money or fame or anything. You get into it because you're curious.
Yeah.
And we get the opportunity to know things quickly and before other people. And that's why it's fun. So the students actually are the ones that do all the work. I don't do any of the work anymore, really. And they're the ones with the newest ideas, and I work with them closely to keep them moving in the right direction.
Yeah.
And it's easy to make bad decisions in science. Somebody once said to me, another professor, actually at the University of Washington, once said to me that the scientific method, the process of science,
Yeah.
is about how many correct decisions you can make in a row. And so let's say you get a data set, you have choices, like do I do experiment 1 or 2 to test something? And perhaps you pick the right one, and then you get to have to make the same decision again next. And so good science comes from making a series of good decisions.
Yeah.
My job is to try and help the students make the good decisions.
Yeah.
The students get the data to make the decisions. So that's why we like it. That's the most rewarding part of the job.
What new topics or technical goals would you like to explore in your future research?
Well, you've tasted some today.
Oh, yes.
You've tasted something that I think is going to change the coffee industry forever.
Oh.
Because if we can make Robusta coffee taste okay, then we have succeeded at something that is, I'd say, quite a big deal.
Yeah.
Because it will take pressure off of the Arabica market. So the 80, 81, 82 point coffees,
Yeah.
we can replace 80 point coffee Arabica with 78 Robusta. That is a big deal.
Yeah, yeah.
Because not most specialty roasters maybe have one 80 point coffee,
Yeah.
and most are 84, 85.
Right, yeah.
But you have that one Brazil pulp natural, or you have the something, right?
Yeah.
So if you can somehow come in with an even cheaper offering, but it's not,
wow.
it's not that it's cheap for, it's not the money. It's that Brazil can
Yeah.
be used in something else now, rather than
Yeah.
a specialty roaster. It can be used for something else.
Awesome.
So if we can figure out that, that's great. And the other thing is, as you tasted today, the barista is a human that can make mistakes.
Yeah.
But if the mistake means that let's say some famous person comes to your cafe
Yeah.
and tastes your coffee only one time,
Yeah.
and that coffee is not what it should be.
Yeah.
Can you imagine if James Hoffman walked into your cafe and you got an over-extracted shot
Yes.
and he served it to him and he's like, I don't like this, and left?
Oh, yeah.
He would never say that, but your cafe would not have been represented
Yeah.
the way you would want it.
Yeah.
Right?
Oh. Okay.
But what if you could know that would never happen, because you could make the measurement, you could adjust it. The barista could. It wouldn't be that you were overpowering the barista. You were helping the barista get to excellent.
Yeah. Okay.
So if you were to create water storage for coffee extraction with limited resources, what is the most important factor?
So for me, I would try and control the dissolved bicarbonate concentration.
Carbon.
Yeah, the baking soda,
Baking soda.
basically.
Yeah.
Because its job is to keep the pH in water from changing much.
Yeah.
And if you try and dissolve coffee acids in the water,
Yeah, right.
then you can't taste them. And they don't. And there's a difference between tasting a coffee that is low in acidity, like for example a pulp natural Brazil or maybe an Indian coffee or something low in acidity.
Yeah.
That won't taste very acidic. But if you brew a coffee that is acidic, let's say a Kenya, and you brew it with the bicarbonate water, that coffee will taste worse because you've taken the acid and turned it into something else, so the molecules no longer taste good. So I think what you want is to control bicarbonate. Yeah.
Do you have any question? Another question? Yeah, okay.
Among the various extraction variables such as grain size and water temperature and pressure, what do you think has the greatest impact on coffee quality?
Yeah, the grind setting. So the grinder, I should say, more specifically. It's the problem that it's not that there's a grinder or a set of burrs that does better.
Yes.
We can make good coffee from any of the grinders in our lab. And we have plenty of grinders. It's that this idea of static electricity formation is pretty significant. And some grinders generate a lot of static. Like conical burr grinder, for example, it grinds slowly.
Yeah.
And it's grinding at low RPM, low speed.
Yeah.
So it's not generating necessarily a lot of static from the low RPM.
Yes.
But because coffee is hitting the burrs often, it's generating more and more static from that. And so conical burr grinders actually are not very good without the water treatment at making espresso.
Yeah.
They make excellent tasting filter coffee, no problem. But I think that if you don't control the static electricity in grinding, and just control grinding in general, I think, if you don't control it, you are in trouble because you don't have the same particle sizes, you have all sorts of other problems. Yeah.
I have a last question.
Yeah, sure.
What kind of approach is needed to make coffee science easily understandable and usable not only for experts but also for general consumers?
I do a lot of work in this field. I spend a lot of time talking to the media, and the media then talk to the general public. You are the media today.
Yeah, right.
I talk to you, and you figure out how to take the science that I tell you and bring it to the form that people need to digest it. My job is to be good at communicating with you.
Yes.
It's not my job to be good at communicating with everybody.
Yes.
And so scientists do a bad job, I think, generally a bad job, of communicating with both the media and everybody. I'm not hiding any information when I tell you about grinding. I tell you exactly these static that's forming. I could put a number on it. I can tell you how much water to add. We're talking about particle size distributions. Most people don't care about any of this stuff. Most people just want to know how much water do I put on coffee, right? We know, because we work in coffee, that it's much more detailed than that.
Yeah.
And so that's my job, is to talk to you about the detail. So for example, dark roast coffees generate large negative charging. Light roasts are small positive charging. They're different. And so you need to treat them differently to achieve the same thing. And you then have to come up with a way of saying that to everybody, which is like add 10 microliters of water per gram or something, or 2 squirts, or whatever it is that you would decide is the right number.
Many people can't recognize the details. So.
And the other thing I'll say, though, is I think that we probably assume that most people are less scientific than they actually are. In the sense that you may assume, let's think, in Korea, if I say to someone in Korea, weigh out 1 milliliter, most people could do this. I think so, right?
Right.
That is something that we teach in first year of university, but most people can do it. So instead of assuming that they cannot do it, I go in with the mentality they should be able to do this and go from there, which is a different mentality than other people may have. Other people may say, let's assume everyone can do nothing. I don't like that idea, because I don't believe that you have to go to university to be scientific. I don't think you need to be formal. I don't think you even necessarily need to go to university at all to be a leader in this. I think that it's a good thing to do, of course. But I don't think that we who choose to go here need to necessarily speak a different language than those that do not.
Yeah.
It's the same.
Yes.
Yeah.
I
Yes.
can understand.
I have to go do exactly the same thing with her.
Oh.
Can you take a picture at the lab?
Of course. Let me give you this.
Yes, thank you.
Oh, thank you. I appreciate.